Hey everybody, today we are talking about 6.3, which is conditions for parallelograms. So in 6.2 we talked about, alright, a figure is a parallelogram, so what properties do we know? Today is more or less going to be the converse of everything that we did in the last section with one exception. So we're going to say, hey, I know these properties. Can I tell if my figure is a parallelogram? So I want you guys in your notes to star this one because this is the one that is new for today. So if I have one pair of sides that is both parallel and congruent, then that is enough information to know that this is a parallelogram. So this one is one that is not, we didn't talk about yesterday, or in the last section. So this one is new for this section, okay? One pair is both parallel and congruent. That is enough to know we have a parallelogram. Everything else that we're going to talk about right now is the opposite of what we did in the last section. So here I have, if opposite sides are congruent, then I know I have a parallelogram. So in the last section we said, if I've got a parallelogram, opposite sides are congruent. Now I'm saying, if I know opposite sides are congruent, then I have a parallelogram. Same thing here. If opposite angles are congruent, my figure is a parallelogram. Okay, and we're going to talk about if diagonals bisect each other, then it's a parallelogram. All right, with this one, we're going to star this one too because there is one important piece. So yesterday, or in yesterday's section, we said if we have a parallelogram, then its consecutive angles are supplementary. A key word here is the word both. So we have to have an angle supplementary to both of its consecutive angles. So x has to be supplementary here and to here. It can't just be one, because if these two angles here are supplementary, that gives us that these lines are parallel. Okay? When these two are supplementary, that gives us that these are parallel, and then we have our parallelogram. So one angle has to be supplementary to both of its consecutive angles in order to know that we have a parallelogram. All right. So it's, again, a lot of the same properties that we talked about in 6.2. Now we're just kind of flipping them around and turning them in reverse. All right. So we want to show that if x is 7 and y is 4, then we have a parallelogram. So I'm going to plug a 7 in for where I see an x. Okay, 7 plus 14 is 21. 3 times 7 is 21. So these sides are congruent. Okay, so I know that BC equals AD, which is 21. All right, if y is 4, I'm going to do 5 times 4 minus 4, and 2 times 4 plus 8. Okay. So 5 times 4 is 20, minus 4 is 16. 2 times 4 is 8, plus 8 is also 16. So now I know that AB is equal to CD, and they are both equal to 16. So opposite sides are congruent. So I know that ABCD is a parallelogram. All right. So again, with this one, we're just plugging things in and showing that they are indeed a parallelogram. Okay, for part B, I want to show that EFGH is a parallelogram when Z is 11. So I'm going to kind of put an 11 right here for Z. And 11 right here, and W is going to be 4.5. All right, so when I plug these in, I'm going to do 9 times 11 plus 19. That is going to give me 118 degrees. All right, 11 times 11 minus 3 is also 118 degrees. 14 times 4.5 minus 1 is 62 degrees. So we know that angle G, okay, is 62 degrees. G and H add to 180 because 62 plus 118 is 180. 62 plus 118 this way is 180. So G is supplementary to both angle F and angle H. So EFGH is a parallelogram. Okay? So again, we have to show that it is supplementary to both of its consecutives. All right, let's look at another example. This one we want to know, do we have enough information to show that our figure is a parallelogram? So in A, I know that this side is congruent to this side, and this side is parallel to this side. All right? Our properties were that the same side had to be both parallel and congruent, or opposite sides, both pairs of opposite sides have to be parallel, or both pairs of opposite sides have to be congruent. This isn't any of those, okay? So this is not enough information because one pair let's say of opposite sides must be congruent and parallel. Okay, it's got to be one side has to be both. So if I had our single dashes over here instead of here, that would be enough to know. But I have it the other way around. Here's why. I can draw parallel lines, congruent, congruent. That is not a parallelogram. It is an isosceles trapezoid. It has all of the same information as this does. One pair of parallel sides, and the other pair is congruent. So that is why it has to be the same pair of sides, both congruent and parallel. Okay? So let's look at B. I've got this piece of the diagonal is congruent to this piece is congruent to this piece. So yes, this is enough to know because diagonals are bisecting each other. All right. Questions there? If you do have them, make sure they get jotted down somewhere so that way you can ask them of me in class tomorrow. All right? Again, our favorite thing ever is our proofs. Okay? We're going to start by drawing DB. So go ahead in your, let me get the right tool here. Notes, go ahead and draw diagonal DB. All right, we are given that AB is congruent to DC and AD is congruent to BC. All right, we're trying to prove that we have a parallelogram. All right, so what we're going to look at trying to do is, again, showing that triangles are congruent like we did in 6-2. And then we're kind of going to work backwards from there. And to get, it's almost, if you look at the notes and you look at your notes from 6-2, it is almost the exact opposite proof. We're moving in pretty much the opposite order. All right. So let's take a look. DB is congruent to itself. That is our reflexive step. Okay. AB is congruent to DC, AD is congruent to BC, that information is given to us. Okay? Side, side, side is a triangle congruence thing. So I can say that triangle ABD is congruent to triangle CDB by side, side, side. Okay? Now, I am trying to get parallel sides because that is how I show a parallelogram. All right? To do that, I say, hey, I know that this angle is congruent to this angle, and this angle is congruent to this angle. All right? That is CPCTC. Okay, now because those angles are congruent, I know that these lines are parallel. That is our AIA converse. If my lines are parallel, I know I have a parallelogram by the definition of a parallelogram. Okay, so again, if you look at the notes from 6.2, this proof is very similar, except we hit like this piece in reverse. All right? Again, I know proofs are not fun, but we're trying to show that our opposite sides are parallel. To do that, we're trying to get these alternate interiors congruent. All right? To get those interiors congruent, we got to show that the triangles are congruent by side, side, side. All right, let's do another one. All right, we have a paragraph proof this time. We're given angles A and C are congruent, B and D are congruent, and we want to show that our figure is a parallelogram. Okay, so first things first, I know that all the angles add to 360. So this is from section 6.1. That's that n minus 2 times 180. That is our polygon angle sum theorem. Okay, instead of polygon, because we actually have a quadrilateral, you can say quadrilateral angle sum theorem. Okay, instead of polygon, if you know the specific polygon. Either one is absolutely fine. All right, we are given that the angle from the givens, we know that the measures are equal. By substitution, we are saying, okay, so here's what happens. If I have A and C are equal, B and D are equal. All right, we know that I'm going to take C here. I know that A is equal to C. And I'm going to take A and I'm going to plug it in for C. So that's where this C becomes an A. All right, I'm going to do the same thing with D. Okay, B is equal to D. So for D, I'm going to plug this in to B, which is why this one becomes a D. Okay, so all we're doing is substituting A for C and D for B. So that way I get AD, AD. All right, which is 2 of A plus 2 of D is going to equal 360. So if we divide both sides by 2, I'm going to get that the measure of angle A plus the measure of angle D is equal to 180 degrees. Okay, what is that showing me? That's showing me that my same sides are supplementary. Therefore, if my same sides are supplementary, I know these are parallel by my same side converse. So this is my same side interior angle converse. Okay, we would go back and do that exact same thing again, except here I would want to have C plus B plus C plus B. Actually, no, I lied. I would want to have A plus C, B, A and B, A and B. I'm sorry. To show that these two are supplementary. Or I could do D and C, and that would give me my other side are parallel. All right? So it's a repeated statement and a repeated argument. So we can say a similar argument shows that those two sides are parallel. Now, you're not going to have anywhere you have to do this little step. I would make you go through the whole process. All right? Any questions on that, make sure you write them down, and we will talk about it in class. I hope you have a fabulous day, and I will see you guys later.